Three Carnot engines operate in series between heat source at a temperature T1 and a heat sink at a temperature T4. So this is T1 and this is T4. Now this epsilon 1 is the efficiency of this first Carnot engine, epsilon 2 happens to be the efficiency of the second Carnot engine, and epsilon 3 the efficiency of the third Carnot engine. Now it is given that they are equally efficient. We know from thermodynamics the efficiency of a Carnot engine is given as E is equal to 1 minus temperature of sink divided by temperature of source. So by this equation we are going to get epsilon 1 to be equal to 1 minus T2 upon T1, epsilon 2 to be equal to 1 minus T3 upon T2, and epsilon 3 to be equal to 1 minus T4 upon T3. Now what has been specified or given to us is the fact that all the three efficiencies are equal. So from these two we get the relation T2 upon T1 is equal to T3 upon T2, which implies T2 square is equal to T1 T3. So this is one relation that we have. The second relation is obtained by equating epsilon 2 and epsilon 3. So if we equate the two, we get T3 upon T2 is equal to T4 upon T3, which would imply T3 square to be equal to T2 T4. Now let us say if we want to eliminate T3 from these two set of equations and find the relation between the three remaining variables, namely T1, T2 and T4, the most prudent method is to square this equation, and after we do square this equation, we are essentially going to get, on squaring this particular equation, we are going to get T2 raised to 4 is going to be T1 square T3 square. So now in place of T3 square I can write T2 T4. So here I'll get T1 square T2 T4. Alright, so this implies T2 cube is going to be equal to T1 square T4 essentially. Therefore T2 is going to be equal to T1 square T4 raised to 1 by 3. So this is one part of the answer. We can check out the options and see that in option B this answer is specified. So we are getting this particular value of temperature T2 in option B. So let us now try to find out T3. In order to find out T3, we would like to eliminate T2 from these two equations. So how do we go about eliminating T2? This time we would rather square this equation and we would get T3 raised to 4 is equal to T2 square T4 square. Now in place of T2 square we can write T1 T3. So this is going to be T1 T3 T4 square. Alright. So now we can cancel 1 T3 from here. So this will become cube. So we get T3 cube to be equal to T1 T4 square, and thus we get T1 to be equal to, or rather T3 to be equal to T1 T4 square raised to 1 by 3. So this is the second part of the solution. So we again confirm that B is the answer. So these are the fundamental equations that we have, and the rest of the question is about mathematically manipulating these two equations that we have in order to reach the answer that we need. Namely, we wanted T2 in terms of T1, T4 and T3 in terms of T1, T4 as well. So the answer is going to be B.